Welcome students. Hoping that all are doing pretty good at homes and studying well. I am going to start a new chapter named Surface Chemistry today. So, surface chemistry is that branch of science or that branch of chemistry which deals with the study of the phenomena occurring at the surface or interface. Interface means at the boundary separating the two bulk phases, that is solid solid, solid liquid, solid gas. When you represent a interface, you will put a hyphen or slash between the two phases involved, like solid liquid interface or solid gas interface. Interestingly, gases, different type of gases has no phase difference because they can diffuse pretty well with each other. Okay, so gases do not have any interface. There are various types of phenomena that occurs at surface or interface. They are adsorption, catalysis, dissolution, and a lot more. Electrode processes, they are also interface phenomena. Okay, so in this chapter you will study about some of the phenomenon that are occurring at surface or interface, some of which are adsorption, catalysis, colloids, emulsions, and the properties associated with them. Okay, now let us start with adsorption. When you buy a new tiffin box or new bottle or new bag, you must have seen a packet written silica gel on it with the product. Okay, so what happens, this packet is kept in the closed container or closed bag, so that the amount of gas present inside it, whether it is water vapor or some type of gas, it gets it is attracted to that surface and is retained on it. Okay, this process is known as adsorption. Now, so you can define adsorption as the phenomenon of attracting and retaining the molecules of a substance on the surface of a liquid or solid into a higher concentration of molecules on the surface is called adsorption. Okay. Now there are various terms associated with adsorption. Let us see. First is adsorbate. Adsorbate are the substances which are adsorbed on surface of other substances. They are adsorbate. Next is adsorbent. Adsorbent are the substance on which the other substances like gases are adsorbed. They provide the surface for adsorption. Okay, they are adsorbent. A similar process but just reverse to adsorption is known as desorption. Desorption means removal of the adsorbed substances from the surface of adsorbent. Okay. If we are using metal as adsorbent, then the adsorption of gases on the metal surface is named as occultation. Occulation or CCLUSION, occulation. Okay. Now let us see the mechanism of adsorption. Suppose, consider this is a liquid and this is a solid object. Okay. Now the situation existing on the surface of the liquid or a solid is different from that of the interior. For example, a molecule in the interior of the liquid is completely surrounded by all other molecules from all of the sides. Hence, the intermolecular forces of attraction are exerted equally in all direction, right? Now, the molecule at the surface of the liquid is surrounded by large number of molecules in the liquid phase and fewer molecules in the gaseous phase. Fewer molecules of the vapor of this liquid in the gaseous phase. That is the space above the liquid of the space above the liquid surface. Okay, there are very less molecules of this liquid in vapor phase than the bulk. So, there is a net unbalanced forces below in the interior and out of the outer phase of this molecule. Now, so what happens? These molecules lying at the surface experience some inward net force of attraction that results in surface tension. Okay, this is the cause of surface tension. Similar inward forces of attraction exist in the surface of a solid also. In certain solids like transition metals like nickel, there are unutilized free valencies on the surface. Now because of these unbalanced forces at the surfaces, they have the property to attract and retain molecules of the gas above the surface, and thus the molecules come in contact and get adhered to this surface molecules and causing adsorption phenomena. Okay, now let us see the features of adsorption. Now when adsorption takes place, residual forces on the surface of adsorption decrease. Therefore, surface energy also decreases and it appears in the form of heat and is known as heat of adsorption. Heat of adsorption, delta H of adsorption. Therefore, delta H of adsorption is always a negative value. That means it is a exothermic process. Now, the molecules of the adsorbers are held on the solid adsorbent. Since they got held at the adsorbent surface, delta S, that is entropy, also decreases. Randomness decreases. Okay. Now you know that delta G is equal to delta H minus T delta S. Now the process to occur or the process to be spontaneous, delta G must be negative. Delta G to be negative, delta H must be negative and should be more in magnitude than T delta S. Right. Now this is the condition for the initial phases of adsorption. Now as the adsorption process proceeds, delta H keep on decreasing and T delta S, delta G is equal to delta H minus T delta S. Now when the adsorption proceeds, delta H keep on decreasing and T delta S keep on increasing till a situation comes when delta H and T delta S becomes equal, so that delta G is equal to 0. Okay, at this stage the adsorption has attained an equilibrium value. Okay, this stage is known as adsorption equilibrium. Right. Now there is a difference between adsorption and absorption. In adsorption is a surface phenomena, whereas absorption is a bulk phenomena. Here the molecule or molecules of other phases diffuse into the bulk of other substance and absorb. When adsorption and absorption are taking place simultaneously, a common name is given to the process known as sorption. Only sorption. Sorption is written when adsorption and absorption both takes place simultaneously. Okay. Now let us see what are the factors that affect the process of adsorption. First is nature and surface area of adsorbent. Okay, adsorbent on which the gases, on where the gases are adsorbed. So greater the surface area, more is the adsorption. Okay. Next is nature of gas being absorbed. Different gases are adsorbed to different extent by the same adsorbent at same temperature. For example, hydrogen, nitrogen, carbon monoxide, methane, HCl, ammonia, etc. all are different gases and they adsorb to different extent to same adsorbent material. So what is the difference? Why it is so different in their process of adsorption? It is observed that the gas having low critical temperature is adsorbed less. The gas having higher critical temperature is adsorbed more. That means if critical temperature increases, adsorption also increases. Now, critical temperature, what is critical temperature? It is the temperature above which a gas can be liquefied with the application of pressure alone. So, when the critical temperature increases, ease of liquefaction increases. Now, critical temperature is also related with the intermolecular forces of attraction. Okay, higher is the critical temperature, greater is the intermolecular forces of attraction. For such a gas, the greater will be attraction of the gas molecule on the surface of adsorbent 2 and hence the adsorption will increase. Okay, now let us see the next factor, that is temperature. Considering the process and equilibrium process. Adsorption is an equilibrium process. It is observed that increase in temperature, with the increase in temperature, adsorption decreases. Now we can write the adsorption or condensation. Adsorption, gases are adsorbed on surface, that means it is getting condensed. Reverse of the adsorption, that is desorption, in which the gases are removed from the surface and we can call it also evaporation. Okay, now what happens? Adsorbate, you can write adsorbate plus adsorbent, a reversal process where gases are adsorbed on solid plus heat of adsorption. It's an exothermic process and heat are released. So when we increase the temperature, since the process is an equilibrium process, it will try to decrease the effect of temperature. So the process will proceed in reverse direction. That means desorption will occur. Okay, it is a forward process is adsorption, reverse process is desorption. In adsorption, heat is evolved, and when we are increasing temperature by applying Lee-Chatelier principle, we will find that the process will proceed in backward direction. That is where the heat got consumed. Okay. Now the next factor is pressure. At constant pressure, adsorption of gas increases with increase in pressure. Okay, increase in pressure, adsorption process increases. It is observed that at low temperature, the adsorption of the gas increases very rapidly as the pressure is increased from small values. Okay. Next is the activation of solids adsorbent. Activation means the increasing the adsorptive power of the adsorbent. So how can you activate an adsorbent? You can activate the adsorbent by increasing its surface area. Only you have to increase its surface area. Then how will you do? You can make the surface of the adsorbent rough, or may divide into smaller pieces or grains, or make it make the adsorbent in powder form. Okay, this all will activate the solid adsorbent. Now let us see the types of adsorption. there are mainly two types of adsorption known as physisorption and chemisorption. In physisorption, van der Waals forces of attractions are involved in the adsorption process. Okay, it is a very weak force, and so it is a physical change, that is no new compound is formed. It is non-specific in nature, and the amount of the gas adsorbed is directly proportional to critical temperature of the gas, as already explained. The process is reversible, that is, it is an equilibrium process. Since it is a physical change, it is associated with low enthalpy of adsorption. Very weak forces are involved in the process, so enthalpy of the adsorption is very low. It forms multi-molecular layer of the adsorption. It forms a multi-molecular layer of adsorbate on adsorbent. With increase in pressure, it increases, and with decrease in pressure, it decreases. Means decrease in pressure will increase desorption. At low temperature, it is a favorable process. As the temperature increases, the desorption increases as kinetic energy of the molecules increases. Low or no activation energy is associated with the process of physisorption. Alright, now let us see the process of chemisorption, which is also known as Langmuir adsorption. Chemisorption is, in chemisorption, the forces of attraction are usually chemical forces. So it is a chemical change, and formation of surface compound occurs on the surface of adsorbent. It is highly specific in nature, and the adsorbate forms the chemical bond with the adsorbent. The chemical bond may be ionic or covalent. Since it is a chemical process, it is irreversible in nature and have high activation energy. Okay. The enthalpy of adsorption is also very high. It forms a unimolecular layer of adsorbate on adsorbent. With increase in pressure, it increases, but decrease in pressure doesn't causes any desorption. As the chemical bonds have formed, it is very difficult to reverse the process. With the increase in temperature, it first increases. Okay, it first increases with temperature, but after that it doesn't have any effect. Thus, it is called activated adsorption. Okay, here low temperature favors the process. Here increases with increase in temperature, it increases because it helps to attain that threshold value. Okay, it helps to attain the activation energy to get that threshold value so that adsorption can occur. Now, the extent of adsorption on a given surface generally rises with increase in pressure and concentration at a constant temperature, right? So, at low temperature, it is observed that physical adsorption of gas increases very rapidly as the pressure rises. But when the temperature is high, the increase in adsorption is relatively less. Alright. Now consider the adsorption as a reversible process or an equilibrium process. When an adsorbent and the adsorbed are enclosed in a closed vessel, after an initial decrease in the pressure of the gas pressure as well as amount of gas adsorbed becomes constant. Okay, that means it reaches the constant value. This happens because at equilibrium, process of adsorption and process of desorption becomes equal. Rate of adsorption becomes equal to rate of desorption. Okay. Now, the extent of adsorption is expressed as x by m. X is the mass of adsorbate upon mass of adsorbent. Okay, it is the mass of gas adsorbed, it is the surface mass of the surface of adsorbent. Okay, it is the extent of adsorption. When it is x by m is taken when the equilibrium has attained. Alright, thus the x by m is the mass absorbed per gram of adsorbent. It expresses the mass absorbed per gram of adsorbent. Alright, so it is also known as specific surface area of the adsorbent. Now when we are plotting x by m, that is extent of absorption, with respect to equilibrium pressure, the graph obtained is known as adsorption isotherm. We are plotting it against equilibrium pressure. Temperature is taken constant, temperature remaining constant, so it's a isotherm. Okay, it is seen that at lower pressure, when the pressure is low, the graph is almost line or a curve. After reaching a certain value, maximum value, it reaches a maximum value. Adsorption becomes maximum. This pressure is known as saturation pressure and written as PS. After that, after this pressure, it is seen that it doesn't depend upon the mass, upon the extent of adsorption is not depending upon the pressure, increase in pressure. Okay, so you can write x by m is directly proportional to P at lower temperature, or x by m is equal to K constant P raised to the power 1. At higher temperature, after reaching the saturation point, x by m is directly proportional to P raised to the power 0, or x by m is equal to K P to the power 0. That means the intervening pressure is ranging from 0 to 1. So we can write the x by m is equal to K P to the power 1 minus 1 by n, where n is the integer. If we are taking solution, adsorption process in solution, we can use concentration term in place of pressure. Okay. This graph isotherm was given by Freundlich and is also known as Freundlich adsorption isotherm. It mainly considers the adsorption as multimolecular process and is applicable only to physical adsorption, that is physisorption. Now adsorption isobars, that is when extent of adsorption is plotted against temperature when pressure is taken constant. For physisorption, it is seen that with increase in temperature, extent of adsorption decreases. Okay. For chemisorption, it is observed that extent of adsorption first increases and after that it decreases. Okay, so this is all about adsorption, and next video we will study about catalysis. Okay, that's all for today. Thank you.